everyone, welcome to the science stuff. Today we are going to be doing the pepper on water and soap experiment. In this video I will include the explanation on surface tension and surfactants too. Hope you enjoy.
So for this experiment I'll be using a plate, one Q-tip, a cup of water, some pepper and some soap. So first I'm going to be putting the water on the plate. There. Now I'm going to be adding some pepper onto the water. There. Now I'm going to take some liquid soap on top of my Q-tip. And now I'm going to dip this Q-tip into the water. There.
Now let's look at the observations. When the Q-tip, which had liquid soap on it, was dipped into the water with pepper sprinkled on it, the pepper started to get away from the soap towards the sides of the plate. Now why does this happen? To fully understand the conclusion, first let's look at what surface tension is. Now let's look at this glass of water. Here we can see all the water molecules. Now if we take any water molecule in the center of this cup, then we can assume that it will attract all of the water molecules to its sides and all of the water molecules around it, right? And all the water molecules around it will also attract the water molecule in the center. This creates a balanced force, and so the net force will be zero. Now if we take any water molecule on top or on the surface, then we see that it will attract all the water molecules to its sides and all the water molecules below it, and all the water molecules below it will also attract it. But there are no water molecules above it, right? Now this creates an unbalanced force, and this causes these water molecules to have a greater force of attraction between themselves, creating a thin film of water on the surface, which is known as surface tension. Now let's look at this circle and let's assume that it is the overview of a cup. Now if we carefully place an iron needle, which has a higher density than water, right on top of it, we will notice that it does not sink. Now this is because this thin film of water is supporting it. If we give even a slight push, this needle will easily fall down. Now what does soap have to do with this? Well, soap is a surfactant, which means that it has a hydrophilic head or a polar head and a hydrophobic or non-polar tail. This means that the head will be attracted to water while the hydrophobic tail repels the water. When the surfactant touches the water, it lessens the surface tension. Now how does it do this? Well, the unbalanced forces causes it to form the thin film of water on the top. Now when the hydrophilic or polar head touches the water, these forces are used to attract the surfactant instead, reducing their attraction to each other, hence reducing surface tension. Now water likes to retain its surface tension, so it moves away from the surfactant, in our case towards the side of the plate. And when the water moved towards the side of the plate, it took the hydrophobic pepper with it. Now this phenomena can be observed in nature. Look at these water spiders glide across water. They depend on surface tension to prevent them from sinking. Here look at this water drop form a dome shape. This is because of surface tension. And if you leave a water drop in zero gravity, then it will form a perfect sphere. Thank you for watching this video. Please like and comment and subscribe for similar content. And you're watching the science stuff.